Let's start here.
I'm gonna glue it back again.
I know, right? Got to put it. This poor guy has
Ours
been
is
through
missing
it.
a cerebellum.
This guy. Oh, is it? Well, okay. This side of the brain we refer to as the superior side. Okay, this is the superior side of the brain. This is your gyri. Okay, it's plural for gyrus. This, what fissure is this? Does anyone remember? Longitudinal fissure. Very good. Longitudinal fissure. What's this little guy? Brainstem. This is your brainstem. What is this whole... Now, I said the longitudinal fissure separates the two hemispheres, but what does this refer to? The cerebrum. This is the cerebrum. So if this is the cerebrum, this is your cerebellum or small brain. Okay? These little worm-like structures here are referred to as the vermis. V-E-R-M-I-S. Vermis. Okay? Let me show you. Yesterday we talked about this. If you take the cerebellum and you pull it down, you're going to have a superior and inferior colliculi. And remember what I said, what does the superior colliculi, what is that responsible for? Yes, vision. And remember I said if you look at it, it kind of looks like eyes if you use your imagination. The superior colliculi, that's responsible for vision. So if the superior colliculi is responsible for vision, what's the inferior colliculi responsible for? Hearing, you got it, hearing. Very good. All right. So now if we turn it around, this is referred to as the inferior part of the brain, the inferior side. So these are going to be your olfactory bulbs. I'm hoping they'll be better on your brains, but these are the olfactory bulbs. What do you think comes out of the olfactory bulbs? The olfactory nerve, the olfactory nerve. Remember I said yesterday, the olfactory nerve is the only nerve that doesn't respond with the thalamus. It's the only one. And remember I asked the question, what does it correspond with? Nobody knew. Did anyone look it up?
What doesn't respond?
No, what does it respond to? If it doesn't respond with or correlate with the correspond with the thalamus, what does it?
Smell.
It's smell. So it's going to be, what is this? What is this whole thing?
Frontal lobe.
And the whole thing is the cerebrum,
Oh, okay.
right? So it corresponds with the upper part of the cerebrum. Okay, it's the only nerve that doesn't correspond with the thalamus. Okay, if we move down, if you use your imagination, this kind of looks like an X. Okay, this is your optic chiasm. Optic chiasm. So what do you think comes out of the optic chiasm?
Optic nerve.
The optic nerve, cranial nerve number 2. Now keep in mind, if the optic nerve was intact, it would be going up just like this, okay? And it's referred to as the optic nerve. However, if it's going down from the optic chiasm, it's referred to as the optic tract. Okay, so if it's going up, it's the optic nerve. Going down, it's the optic tract. Okay, again, this is the optic chiasm. Right here, if you put the brain together, you're going to see a little hole. What's that little hole? Does anyone know? Talked about it a little bit yesterday. It's called the infundibulum. The infundibulum. So if I take my pointer and I put it in the infundibulum, what would this be if it was still intact? Coming out, hanging from the infundibulum, what would it be? It was removed during the when they prepared this for dissection, but What would that be?
Pituitary?
Yes, very good. The pituitary gland. The pituitary gland. Excellent. These little bumps right here are the mammary glands, or mammary bodies, right here. Okay. So again, if this is the brainstem, what's the first little bump we come to? Medulla oblongata. Medulla oblongata. And up here would be your pons. Very good.
Is there anything like distinguishing that separates them?
No, well,
any-
the first little poof here is going to be the medulla oblongata. So if I have a pin here, you know that's what it is. If I have a pin up here, it's going to be the pons. Okay.
The midbrain,
Midbrain's going to be up here.
all the further.
Yeah,
Kind of.
further up a little, yeah. Okay. How about the lobes? If I turn it back around to the posterior side, what lobe would this be?
Front.
And
No,
no,
temple's on the side.
parietal and temporal. Very good. Okay.
For the lab, Dr. P, are we going to, myself, Steve, are we going to have fake brains or real brains?
No, real brains.
That's a great
That's
one.
where you're keeping them. Yes. Okay. When you go to dissect, guys, this is so easy. If you'll find that there's very little holding these two hemispheres together. So you just take your scalpel and very lightly you're going to do this, and it's going to come right apart, and then you can turn it over and you can cut the rest of this in half. Okay? So what you're going to have is two halves. Okay? They're all going to be a little bit different depending on the cut, but this is what you'll have. So let's start with,
Arbor vitalis is pretty significant. I didn't think you could see it that easily.
yeah, it's awesome, isn't it? It's great. Okay, so let's start with this half. This rubber band-like structure is referred to as the corpus callosum. The corpus callosum. And inside the corpus callosum, what do you think we're going to find? Yeah, you're going to find the lateral ventricle. The lateral ventricle. And if you pull this apart, you can see some darker pigmentation there. And that's referred to as the choroid plexus. And that choroid plexus is going to have epidermal cells. And those epidermal cells are going to produce what?
CSF.
You got it. The CSF, cerebral spinal fluid. Okay? So this is the corpus callosum, the choroid plexus. You're going to find the lateral ventricle, and the CSF is going to be produced by the epidermal cells. Okay? If you come down, you see this little round guy here? Might be able to see it better on this side. It's right here. See the little round? This is your thalamus. This is your relay center for every nerve but the ophthalmic nerve, or the ophthalmic nerve. Right above the thalamus, what do you think you're going to find? It's another ventricle. I'll give you a hint. It's the third ventricle, right above the thalamus. The third ventricle. Below the third ventricle, and it's very hard to see on mine, but right in here would be the hypothalamus. Let's see if I can see it on here better. This is your thalamus. Gosh, it's so hard to see. I won't pin it because it's almost impossible to see. I'll pin the thalamus, but not the hypothalamus. It's going to be, this is part of your optic chiasm right here. So your hypothalamus is going to be right in here, but it's very, very difficult to see. And we're going to talk more about the hypothalamus next semester when we talk about the endocrine system.
I thought we were going to fully skip the endocrine
No,
system.
we're not going to fully skip it. No. Okay. And then here is your cerebral aqueduct. Okay, right in here. cerebral aqueduct. And if you follow it along, this will bring you to your fourth ventricle, right in here. And what is this whole thing? Cerebellum. This is your cerebellum. Okay, so this is going to be your fourth ventricle. This little guy here is what I was talking about earlier for balance and equilibrium. This is your follicular lobe or lobule, right here. That little guy is responsible for balance and equilibrium. Okay? Any questions on the brain?
It's cool to see it up close.
Yeah, it's neat, isn't it? Yeah. Okay. I think that's, oh, the pineal gland, I ripped off mine. He's right here. It's right there, and it's going to be right above, superior to your your thalamus. It's going to be right in here. You'll be able to see it. I'll come around and point it out to you. Okay, yeah, it's real tiny. Okay. All right, any questions on the brain? No? Okay. Okay, let's go to the eye. I've already dissected this, so it's
Crazy.
yeah, what I recommend you do, the first thing you're going to do with your eye is turn it upside down, and you're going to find your what? What is this? Huh? It is the optic nerve. You're going to find your optic nerve, and you're going to, because you want to keep it intact when you're dissecting. So you're going to take your scalpel, and you're going to cut away all this muscle, okay? Some eyes are bigger than others, so they're going to have more muscle, but you want to cut all this muscle away without disturbing the optic nerve. And then you're going to turn it around, and when you're ready to, when you got rid of all that muscle, you're going to make an incision right here, and some stuff is going to come out, okay? It's like a jelly-like substance. Does anyone know what it's called? It's referred to as the vitreous humor. The vitreous humor. And it's jelly-like, and that jelly-like substance is going to be behind the lens. So if the vitreous humor is behind the lens, what's in front of the lens? It has to be clear. It's the aqueous solution. It's like water. Okay, that's going to be in front of the lens. So just be careful when you make your first incision. It may get a little messy. Well, it could. You just want to. You just want to be careful. Okay. So you're going to cut. You're going to make an incision and go all the way around the eye, all the way around the eye, and then you're going to open it up, kind of like a book.
When you took off the muscle, did you take off the eyelid too?
It didn't have an eyelid.
Oh.
Yeah.
Ours does. Ours does.
Oh, does it?
It's like covers the whole eye.
Wow. Okay, now before I go further, what is this? Yes, very good. This is the cornea. Now you're going to say the cornea, why is it so cloudy? Well, in life it's not. In life it's very clear so you can see. In death, the proteins become denatured and it becomes cloudy. It almost looks like a cataract in a human, okay? But, yeah, right. But that is your cornea. So we cut it open, we pull it up, we open it like a book, and let's start on this side. Now this was sitting in there just like this, and it had the vitreous humor that came out, okay? So what do you think this is? Does anyone know? I cut it in half because I wanted to show you, but this is the lens. Now, when you feel this, it's super, super hard. It's like a marble. It's not like that in real life. I mean, in life, it's not like that. It's soft. Oh. I'm so sorry.
We're throwing eyeballs.
I'm so sorry. And it's the whole, there we go. I know, right? That was great.
Then you can go home and say, hey, guess what happened to me today?
Hey, we could have a game with this. It's pretty cool. But they're very slippery, so be careful when you cut them, when you slice them in half. But when you slice them in half, on some of them, you can see the crystals. And the crystals is the protein that's become denatured, and that's what makes it so hard. But just keep in mind, in life, it's soft because it has to move. Okay. Sorry about that. I shot you with... I've never done that before. I hit a student with a lens. Okay. Okay. This here, this white here, and it's almost like a rubbery texture, it's referred to as the sclera. Okay, that's the sclera. So if this is the sclera, this dark area is the choroid. Okay, this is the choroid. Okay. What about these ridges here? You see these ridges? This is referred to as the ciliary tract or the ciliary body. Okay, ciliary tract or ciliary body. And inside, right here, you see this black here? That's the iris. And what's the iris responsible for? Color? Color, okay. So let's come over here to this side. Now, I've bunched this all up, but this membrane, if you're dissecting, if you just cut this open, this membrane covers this whole lining, okay, this brown membrane. What do you think it is? It's your retina. It's the retina. So it's, like I said, it's going to cover this whole area.
The cones and...
So if you take this and you pull up on the retina, okay, you're going to be able to pull it all the way out except for this little bit. And what do you think that's attached to?
The optic nerve.
You got it. It's attached to the optic nerve. Okay, so this is your retina. It's attached to the optic nerve. What's this little guy here? I'll give you a hint. We don't have this. Humans do not have this. This little, yeah, this little pretty shell, like it looks like mother of pearl. Does anyone know what it is? It's called the tapetum lucidum. Tapetum lucidum. And guess what it's for?
It's reflective off the lights that
It's,
you see when
it's
you
for
have
night
lights.
blindness.
Yeah.
It's for night blind, or not night blindness, for night vision. It's for night
A lot of other
vision.
mammals, like
Yeah, right. So if you ever taken a picture of your dog and cat and they look like they're possessed, well, they're not possessed. It's because of the tapetum lucidum. Okay, and it enables them to see at night. Okay?
thank you, evolution. We lost that.
I know. I think we should have that, right? Okay, and that's your eye. Any questions at all? No? Okay.
Let's get to cutting.
Let's get the